At the risk of stating the obvious, deserts are often difficult places to live in. By definition, a desert is a biome that is relatively lacking in water. As water is foundational for life as we know it, this lack presents a serious obstacle for the resident forms of life. Whether plant or animal or anything else, any species that lives in a desert must have adaptations to survive. These adaptations most often center upon either conserving water or surviving the desiccation of tissues. There are a great many interesting stories of such adaptations, but for today I will focus on just one group. This is a familiar group of plants, easily recognized and quite distinctive. They are the cacti within the family Cactaceae. Many species are popular choices as low-maintenance houseplants. They also often appear in various cartoons and other bits of popular culture. Such familiarity may often cause us to forget just how unconventional their anatomy and physiology tend to be. If a person had no such familiarity, they might easily believe that these plants were not plants at all. They might easily believe that they were altogether alien forms of life. To begin with, I should take a moment to address the name. The word cactus appears to be a Latinized version of the Greek word cactos. Supposedly this name was used by the Greek philosopher Theophrastus in reference to a now unknown variety of spiny plant. Such are the little twists and turns of etymology. It might be more helpful to define what a cactus actually is. To properly do so, one should also define what a succulent is. A succulent is any plant that has thickened, fleshy tissues adapted to water storage. Not surprisingly, succulents tend to be found in arid environments. There are a few species among the Cactaceae that resemble normal plants with the conventional patterns of leaves and stems visible above the ground. The vast majority, however, are the familiar highly modified cacti. Every such cactus is by definition a form of succulent. That being said, there are a great many species of succulent that are not cacti. The most reliable defining trait for a plant within the Cactaceae is the presence of specialized structures known as areoles. In a typical cactus, each areole is a raised bump on the swollen stem, most commonly adorned with spines of some sort or another. In effect, each spine is a highly modified leaf, while the supporting areole is a highly modified stem. It is worth mentioning that the spines are entirely distinct from the thorns found on some other plant species. Thorns are modified stems, while spines are modified leaves. That being said, the functions are often quite similar. The spines of most cacti have defensive functions, keeping would-be herbivores away. This robust and often brutal defense is all the more necessary as the underlying stem is a water storage organ. Water is a precious thing in the desert, and many species will go to considerable lengths to obtain it. Thus, many cacti are enclosed within a halo of vicious spines. While the defensive function is obvious enough, there is another intriguing aspect to this dense covering of needles. They tend to break up airflow around the cactus, slowing the water loss from the epidermis. The fact that the epidermis also has a thick covering of waterproof wax minimizes this loss even further. Beyond this, cacti tend to utilize a remarkable little adaptation in their photosynthetic processes. The epidermis is covered in many small pores known as stomata. These stomata can be opened to breathe in carbon dioxide for photosynthesis, and they can be closed to prevent water loss. The trouble is, during the day when light is available, the temperature is usually too high to safely leave the stomata open. The plant cannot obtain the carbon dioxide needed for photosynthesis without losing a great deal of water along the way. Cacti and many other plant species have a way around this issue. They typically open their stomata at night when temperatures are lower and store the carbon dioxide they absorb as a form of organic acid in their tissues. During the day, the stomata are closed. The accumulated organic acids are slowly broken down into carbon dioxide throughout the day, and this is used in photosynthesis. This overall strategy is known as crassulacean acid metabolism, named after succulents in the genus Crassula, where it was first properly characterized. There are hundreds of cactus species within the family, and the vast majority of these are found in the New World. They are particularly abundant in arid regions of North and South America. However, there are a number of species that live in wetter regions, and some live as epiphytes growing on larger plants. One such species, Rhipsalis pacifera, is found in tropical Africa and Sri Lanka, as well as the Americas. Even among the desert species, the variety of cacti is considerable, with many different patterns of growth, colors, spine structures, and so on. As such, it is perhaps a fool's errand to try and adequately describe them all, at least within a reasonably short span of time. So instead, let us focus on a particularly famous and noteworthy species. Carnegie gigantea is one of the larger species of cacti, as one might guess from the species name. It is a columnar form of cactus that can grow to over 40 feet high, with a stem that is typically anywhere between 1 and 3 feet wide. These plants often live for over a century and a half, and most develop additional stems after perhaps the first 70 years or so. These side arms give the cactus a silhouette that is quite easy to recognize. Most know it commonly as the saguaro or the saguaro cactus. Saguaros are native to the Sonoran Desert and are typically found in southern Arizona and the adjacent Mexican state of Sonora. Like many other cacti, the stems have noticeable ridges along their length. Beneath the ridged exterior, there are corresponding ribs of woody tissue that provide underlying structural support. This pleated pattern allows for rapid expansion of the stem as the cactus absorbs large amounts of rainwater. The root system can extend up to 100 feet away from the plant, allowing it to make the most of even brief periods of rainfall. As with most columnar cacti, the spines arise from areoles located along the apex of each ridge on the stem. They are quite sharp and can often grow to the length of a human finger. This provides an adequate defense for the plant, and there are a few interesting anecdotes connected to this. For example, there is a story of a bighorn sheep that apparently butted heads with a saguaro and lost. The skull was later found pierced by spines. Somewhat more clearly documented is the unfortunate case of one David Grundman. Apparently, in 1982, this somewhat unwise individual decided to occupy himself by shooting a particularly large saguaro with a shotgun. One of the arms fell off and landed on him. This wouldn't have been so bad apart from the fact that this arm weighed about 500 pounds and was covered in wickedly sharp spines. Apparently, shortly thereafter, the main trunk also fell on him, leaving both the man and his car quite thoroughly crushed. Despite the hazards, the saguaro is on the whole a beneficial sort of plant. It is regarded as a keystone species within its native ecosystem, providing an important source of food and shelter for many animal species. Regardless of the spines, many birds nest within saguaro trunks. A few species, like the Gila woodpecker, are able to excavate nesting chambers. To prevent water loss, the plant reacts by forming a hardened callus lining the interior of these excavations. Several other bird species use these nesting sites after their original makers have departed. After the cactus dies, the callus remains as a hollow structure sometimes known as a saguaro boot or a cactus boot. Such structures were sometimes used as water containers by local humans. The ribs are relatively soft as wood goes, but they have been widely used as construction materials for various purposes. The fruits of the saguaro are bright red when mature and edible for humans. Native tribes made a point of harvesting these fruits regularly. Seeds could be separated out and used as the basis for bread, while the fruit itself was typically boiled down into a syrup for preservation purposes. The flowers are pale and fairly large, about 3 inches across, with a strong smell vaguely reminiscent of overripe melons. Whether it is because of their own distinctive appearance or the plant that produces them, the saguaro cactus blossom is the state flower of Arizona. These flowers produce abundant amounts of both nectar and pollen, and thus provide a considerable food source for a number of pollinators. Some of these, like local bees, are to be expected. The white-winged doves are somewhat less expected. They act as pollinators, and they also feed on the fruits. More than half of their diet appears to be derived from the saguaro in one way or another, at least among the Sonoran populations. Perhaps the most surprising pollinator for the saguaro is a local species of bat. The Mexican long-nosed bat, Leptonectarus nivalis, is a fairly specialized nectar and pollen feeder. It tends to feed mainly on the nectar of various agave species, but it will also visit flowers of the saguaro and some other cacti. Interestingly enough, about a quarter of all known cactus species are at least partially pollinated by bats. This is reflected in the flowers of these species, which tend to be relatively large and pale, with strong odors of a musty or fruity sort. This pattern would seem to be ideal for drawing in nocturnal pollinators, as color is of little use in low-light conditions. As for the reasons for this preponderance, many theorize it has to do with the hot, arid habitat of southwestern deserts. Flowers lose water at a considerable rate, so there is a certain advantage to having them open at night rather than during the day. Beyond this, the distance between blossoms may be easier for larger creatures like bats to traverse when compared with insects. Returning to the saguaro in particular, it is worth noting that it forms its blossoms around the uppermost part of its stems. This is one possible reason for the cactus to produce additional stems as it grows older. After all, a saguaro with even a single arm beside its main stem will produce twice as many flowers and potentially twice as many seeds. While the saguaro is a remarkable plant on many counts, it is only a single species within a large and varied group. Next time, I will take a closer look at a genus of cactus that is both famous and infamous, with many interesting connections with humanity. Thank you for listening. I hope you have enjoyed this brief glimpse into the more unusual side of the natural world. If you wish to know more, here are a few things that might be worth looking into. If you found this enjoyable, feel free to leave a like. If you think others would enjoy this content, by all means, share. If you have something to say or ask about, honest comments are always welcome. If you wish to see more from this channel, a subscription would be most helpful. Until next time.